Hi, this is Leslie Langnaw with Design World Magazine, and I'm here at the Rapid Show with Jonah Meyerberg, who is Chief Technology Officer and co-founder of one of the more exciting technologies on the floor today, desktop metal. So tell me a little bit, how did you guys come up with an idea of making a desktop additive machine that works in metal? There's so many safety hazards that have to be overcome.
That's true, and that's really what inspired us to do it. We wanted to get away from the safety requirements and safety hazards that are behind traditional metal 3D printing. So with common additive, laser-based additive manufacturing systems, you have a powder bed, and those powders can explode. Those powders are dangerous. You've got lasers flying all around. It's just not a office-friendly type of process, and we wanted to bring additive manufacturing of metal into the engineer's work, into his office.
So this is the size. This is the size of the system.
That's right.
So what did you do to the metal to make it something that can be extruded?
So we bind the metal with a concoction of polymers. So a binder system that's developed to be very printable and still allow the metal to be highly loaded within it. And it's these rods that you see feeding into the machines, and there's on display over here in different materials.
Yeah, I saw the rods.
The rods have a very high percentage of metal powder inside of them, and a low volume percentage of binder, but the binder allows the powder to flow and keeps it in place so that it doesn't dust up in the air and cause harm.
Now, what kind of metal materials can you do this with?
That's the beautiful thing. Unlike some other 3D manufacturing processes, bound metal deposition is basically standing on the shoulders of the metal injection molding community that's been operating for the past 40 years. Metal injection molding has hundreds of alloys that have been developed for injection molding and then for densification, and we have access to them all.
So now, once somebody builds a part, the part has to go through a furnace heat treatment kind of a post-process?
That's right. So because the part is part polymer when it's printed, we need to remove those polymers, creating a very porous structure, and then we consolidate the powder into a finished part that is over 99% dense.
Wow.
And we do that consolidation all at once. Instead of layer by layer by layer in powder bed deposition, and like laser deposition, we do that consolidation all at once, and so you get very homogeneous microstructure and metallurgy properties in your part.
So that in a way that can be better than some of the other systems, because you do know what's going on in the metal part. You know if there's any gaps or holes or anything within the actual part.
That's right. When you build up a part using a laser approach, layer by layer, the part thicknesses, the wall thicknesses, the geometry can actually affect the microstructure of the part. And so you're not really sure what you've got. In the bound metal deposition process, we take the entire part up to temperature all at once. The consolidation happens all at once, and so the thermal profile in the furnace determines the microstructure at the end, and it can be tuned.
So you have software that an engineer can use to just kind of see how this final stage is going to perform?
Yes, it's a cloud-based software that we built ourselves. It starts with this slicer to help you build the part, help you support it where it needs to be supported, add interface layers between the support and the part so that when the part comes out of the furnace, it can just be lifted off of its supports. The entire strategy that goes behind building the part is stored in the system. It's a cloud-based, and that part is now transferred to the furnace. The furnace knows what it's going to be, baking, what it's going to be sintering. The software has told it, so it knows the sintering profile that it needs to make. And everything is talking to itself, talking in...
I understand this is for the desktop engineer, so this is like for prototyping, maybe some small parts manufacturing, but you also have another system that's more for production?
That's right. We have designed the studio system to be your solution to 1 to 100 parts.
Okay.
Low volume prototyping, get the part right, iterate it, determine what you want, but design it for additively manufactured. Once you've got your product, your part designed, and you've printed it and you've used it, it's a fully functional part, you can then take it into mass production using our production machine. So the DM production is designed to print over 100 times faster. So now we're talking about 100,000 parts that we're cost competitive with.
Okay. Now, some exciting news that was released this morning is that Stratasys is a partner with you in a distribution type of an arrangement. Do you want to talk about that a little bit?
Sure, yeah. So Stratasys has always been a very close partner of ours. They were an early investor, and they're a good friend. The 3D printing community is still very small, and we all know each other. But what Stratasys brings to the table is this network of distribution for 3D printers and this know-how. The best technologies often aren't the ones that succeed. You need distribution with your technology, and Stratasys is a great partner.
So now, if engineers want to find more about your systems, what's your website? Where can they go to?
They can go to www.desktopmetal.com. Brand new website that we launched last week. A lot of great information on there, a lot of videos, and some really cool pictures.
Thank you so much.
You're welcome. Yeah, thank you.
Thank you. And that's the news with Desktop Metal here at the Rapid Show.